So in this video we will study about the entropy. As we have seen in the previous video that the entropy is the main driving force for any spontaneous process. So what is the meaning of entropy? Entropy can be viewed as a measure of randomness or disorder. So for an example, if we are in a class, so this is like our class and students are sitting on a bench, 9 students are sitting here, and once the class is over all the students are here and there, right? They go, some go this direction, some go that direction. So these are the, in all directions students are going after class. So what happened here? Everything is in order, entropy is less. Here everything is disorder, right? So entropy means disorder, entropy means randomness. We are watching movie in a movie theater, everybody is sitting on the chair, entropy is almost zero or nothing, everything is in order. Once a movie is done, all the audience are leaving the theater and they are going in left direction, right direction, everywhere. So now the disorder has started, increases, so their entropy increases. Entropy was designated with the S, right? Capital S is represented the entropy. So the driving force for the spontaneous process is an increase in the entropy of the universe, delta S, S final minus S initial. So for an example, here in this class, in this case, this is the entropy of initial, and here entropy is final, right? Initial. So if we have to find out the change in entropy of a class students, how we can find out? Entropy of the final state, which is higher, and minus entropy of initial. Then we can figure it out what is the change in entropy. So delta S will always be positive for a spontaneous process, right? And it is considered that entropy of the universe is continuously increasing, means randomness in the universe is continuously increasing. And the term entropy was introduced or explained first time in 19th century by this French physicist Carnot. So entropy is the thermodynamic, actually it is what it was explained, the theoretical model of the steam engine. So steam engine came in 19th century and the efficiency of the steam engine was explained through the entropy. So entropy is a thermodynamic and state function, was first introduced in the considering of the efficiency of steam engine. For the Carnot cycle, theoretical, what is the Carnot cycle? Carnot cycle is a theoretical thermodynamic cycle where the sum of the heat over temperature, Q over T, around the closed path is equal to 0 and therefore defined as a state function. So here I have drawn this Carnot cycle because this picture is not very clear, so let me explain here. So in this Carnot cycle, pressure is denoted on the y-axis, which is increasing, and volume is increasing from left to right. And this is the closed system, A to B, this is like a to B and and B to C and C to D. So A to B process is called isothermal expansion, B to C process is called adiabatic expansion, C to D process is called isothermal contraction, and D to A process is called adiabatic compression. So the heat over temperature is positive when isothermal expansion happen, and the same amount become less than 0. So this become negative, and adiabatic expansion is Q over T is 0, and adiabatic compression is also Q over T is equal to 0. And what are the meaning of isothermal and adiabatic? Isothermal process are those process which occur at constant temperature, and adiabatic process are those process where no heat is exchanged, heat was not exchanged during the process, right? And if we combine all the Q over T in this process, the sum of the Q over T around the cycle is 0. So there must be a state function, that is why that is given by this expression. So this was about the brief about the Carnot cycle that was used to explain the efficiency of the steam engine, and based on this they said that entropy is a state function. It means if we have any material which is on perfect crystal or in solid or in a liquid or in a gas, so entropy of these state change based on like this one. Perfect crystal have the lowest entropy, S for entropy, and then solid have more entropy, solid molecule, the molecules in the liquid they have more entropy, and the gases molecule have the highest entropy, right? So entropy increases based on the state. So next important thing is this one, that we can summarize or we can understand this same phenomenon through this slide. So here you can see this is reverse of the previous one. Gases molecules are everywhere, where they are very far, they are very random. So gases molecule are very random, right? They are very random, and if they are very random, it means we have a entropy is very high for the random process. For the random liquid molecule they have less randomness, so their entropy is less than gases. And solid molecule they are kind of very close to each other. This is amorphous solid. So amorphous solid still they can move little bit, not too much, so in their entropy is further less because the disorder is less. And perfect crystal they have highly ordered molecules in the crystals, that is why they have very less opportunity to move around or moving in everywhere, so their entropy is the lowest one. So this is the order you must remember. This is very important, that what are the phases they have and what is the order of the entropy based on their state. So let's see what are the contribution, what are the main factors which are affecting the entropy: temperature and number of moles. So if temperature increases, higher temperature higher entropy, lower temperature low entropy, right? So if temperature increases, what happen? Basically kinetic energy increases. Kinetic energy increases. If kinetic energy increases, molecules get more opportunity to in the mobility, right? Their mobility increases, and if their mobility increases, basically their entropy increases, means randomness increases. So as you will give, that is why hot water have more entropy than the ice. So like steam or hot water compared to ice or low or water at room temperature. Another example is change in the number of moles during the reaction. More mole, more randomness, less mole, less randomness, right? If we have you can understand that when we go to the office or in the parking lot, we can see many cars are there, many peoples are there, so there is more randomness. And if we are in at home, we are only 2 people or 5 people or 6 people, and there is a much more randomness decreases. So number of moles higher, more entropy, number of mole less entropy. So this is the way we can understand the factors affecting the entropy. Another factor which affect the entropy is this one. Entropy is an extensive property. Extensive means it depend on the mass. Entropy increases as the amount of substance involved in the process increases. So it depend on the amount. In extensive properties are those properties which depend on amount, how much you have. Entropy increases the number of atom in the molecule. So number of more molecule, number of more atoms, entropy will increases. So here for an example, this is in this picture it shows the vibrations and the rotation. These are the vibration means 2 atoms are moving in this direction, going and back and forth to each other, or they are moving left and right, or one is stretching, one is contracting, or they are moving in rotation. So these are the possible vibration and rotation or movement are considered for the molecules. And based on this one, if we have for an example carbon is attached with the hydrogen, 4 hydrogen, methane gas, CH4, and if I compare with the CH3 ethane, if we compare the propane, CH3 CH2 CH3, so if I compare these 3 molecules, methane, ethane and propane, so entropy is increasing here. Entropy is increasing. So why? Because number of atoms are increasing in the molecules. Another example, we have seen this one earlier. This ice have less entropy compared to liquid and compared to water vapor. And thus we can also summarize like this one, that gas molecule have higher entropy than the liquid, than the solid, and perfect crystals have the least entropy. So they have very less randomness. So in the next video we will see some more examples related to how entropy changes in the solvation, or how we can count, how we can find out their sign.